Okay, this is 1.3. Use midpoint and distance formulas. Vocabulary. What's a midpoint? The midpoint is a point that divides a segment into two congruent segments. So in other words, it's the point that divides a segment in half. So if this was 1 and 1, this would be the midpoint. A segment bisector is a point, a ray, line segment, or a plane that intersects the segment at its midpoint. So going back to our picture, this is the midpoint. This line would be a bisector because it cuts this segment into two equal halves. Now, also realize that it doesn't have to be perpendicular. You can cut it at an angle, and it's still a segment bisector. So, let's use example 1. Find segment lengths. So we know that point T is the midpoint. And we know it's the midpoint because of these little hash marks. Those hash marks tell us that one side is congruent to the other side. The lengths are the same. So R to S is the segment R to T and T to S. And then we can put in 21.7. And then we also know that TS must be the same, so 21.7. So when we add these together, we will get 43.4. So length of R to S is 43.4. Okay, on this checkpoint, I'm going to start you off a little bit because I don't want you to just put the answer down. What I want you to say is, it says find AB. So let's write down how we're going to do that, because geometry is big on how you did things. AB equals AC plus CB. And then again, why am I not writing the segment sign above it? Because I'm not talking about the segments themselves, the shape of them. I'm talking about the numerical value of their lengths. So now, for the second statement, now go ahead and insert your numbers and then add them together at the end. So I want this nice 3-statement problem solving. Okay, example 2. Point C is the midpoint of BD. Find the length of BC. Write and solve an equation. So since C is the midpoint, we know that BC equals CD. Now we can substitute in for what we know about BC, that it's 3x minus 2. And CD is 2x plus 3. So we are going to subtract 2x from each side. So we get x minus 2 equals 3. And then we're going to add 2 to each side. So x equals 5. Now evaluate the expression for BC when x equals 5. So let's go back up to the original question. A lot of people miss this on the test because they'll circle this as their final answer. Is that what they wanted? No. They wanted us to find the length of BC. The length here of BC. And to do that, we have to put our 5 back up in here. So BC equals 3x minus 2, which is 3. Remember to put the 5 in parentheses. So if we had some negative signs here, it wouldn't mess up our multiplication. Minus 2. 15 minus 2 is 13, so BC is 13. Okay, checkpoint 2. Again, I'm going to start you off. So, let's read carefully. Point K is the midpoint of JL. Find the length of KL, the whole thing. So, let me start you off with this. JK equals KL. Now substitute for what you know. Solve it for x. And then put x back in both of these places and add them together to get the whole length. Midpoint formula. Midpoint formula is just to find the middle of a line. To find the middle of a line is not very complicated. All you have to do is add the x's, divide by 2. So we're averaging the points to get the middle. And then add the y's, divide by 2. We're averaging those points to get the middle over here. And then we just pull these two middles up. That's our midpoint. Okay, example 3. Find the midpoint. The endpoints of P are negative 2 and 5 and 4 and 3. Find the midpoint. So I'm going to go ahead and add the x values, 2 and 4. Then I'm going to average them by dividing by 2. Then add the y values, 5 and 3, and average them. 4 minus 2 is 2. 2 divided by 2 is 1. 5 plus 3 is 8. 8 divided by 2 is 4. So the midpoint is 1, 4. Do you see how that works out right? So you can always check these by plotting them and then finding the middle of that line. Okay, B. Let xy be the coordinates of the endpoint. Use the midpoint formula to find x and y. A little bit more complicated. So they gave us the midpoint. It's always labeled as a capital M. And they gave us one of the endpoints. They want us to figure out what this other endpoint is. So we need to add the x values. What's our first x value? What's 1? Right here. What's our second x value? Well, we don't know, so we're going to leave it as an x. And divide by 2, but that's going to equal this 3. Now, how can we figure this out? Well, let's multiply both sides by 2 to get rid of the 2 fraction denominator, like that. So now we have 1 plus x equals 6. And what plus 1 equals 6? 5. Okay. And I can check that by looking at my line and saying 1, 2, 3, 4, 5. Is that about x over? Yeah, sure. Come on, my y point. I'm going to say 6 plus y equals, divide by 2 equals the y of the midpoint, 4. Multiply both sides by 2. I get this, and so y is 2. Does that look right? 1, 2, sure. So my midpoint is 5, 2. Okay, on this checkpoint, they give you the 2 endpoints, so you are going to add up the x values x1 plus x2, divide by 2, and you get the midpoint x, and then you're going to do the same thing with the y. On 4, they give you one endpoint in the midpoint, so you're going to say x1 plus just a plain x over 2 equals the midpoint x that they give you right here. And so this number will go right here. Multiply both sides by 2 and solve for x. Do the same thing with the y. Okay, the distance formula. The distance formula is a more complicated way to say the Pythagorean theorem. So if we're going to try to find the distance between A and B, what we can do is draw a right triangle around those two endpoints. And then we can use the Pythagorean theorem to find this distance right here. Now, how do we know how far it is from here to here? Well, we know that because we can subtract the x values. How do we know how tall it is? Well, we can subtract the y values. And then we add them up, take the square root, and we get this distance just as if it was a right triangle. So let's look over here at example 4. Let's go ahead and draw the right triangle so we can visualize it. So, how long is this? Well, we could count if we needed to. 1, 2, 3, 4, 5, 6, 7. But we could also say more mathematically. We could say -4 minus 3, and that's -7. What happens to -7 when we square it? Well, it becomes positive. So we'll just have 7 squared, or 49. Now how tall it is? Well, we could count 1, or we could say it's 3 minus 2. Okay, and that would be 1. 1 squared is 1, so square root of 50. Okay, and then they want you to use a calculator and approximate that. So let me look real fast. Okay, square root of 50 is about 7.07. This little line here means approximately. So again, the length of RT is about 7.07. Let's do another one of those real fast, just because I want to make sure you understand it. So let me draw a little graph. You don't have to do this on your paper. Just listen to this one. So let me put a point at 3, 1, and let me put another point at -1, 3. Okay, let's visualize our right triangle through these points. There we go. And then again, how long is it? Well, we could count if we had to, but we could also subtract the the x values. So let's do that. Let's say 3 minus a -1. Be careful with the negative signs in here. Okay, minus a negative is a positive, so that is 4. And when we square it, we'll get 16. Now, how tall is it? What is 1 minus 3? It's -2. -2 squared is positive 4. So that would be the length of this line is a square root 20. Okay? Okay, so go ahead and do the checkpoint at the end, and that wraps this up.